This is the Math 2 lesson summary video for the lesson entitled Congruent Triangles to the Rescue. In Lesson 4, Congruent Triangles to the Rescue, the purpose of this lesson is to use our congruent triangles criteria from the previous lesson, angle, side, side, angle, side, 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 angle, angle, side, and hypotenuse, leg, to justify properties of other geometric figures. We continue to use our definition of transformations as well as properties of congruent triangles to support our arguments. So in part 1 of this task, we read that Zach is thinking that every isosceles triangle has what we call a line of symmetry that passes through the vertex point of the angle, made up by two congruent sides and the midpoint of the third side. And we were discussing what we think about Zach's claim. So what we did for this first part is we took an isosceles triangle and we physically folded it along the line of symmetry to see if his claim is true.
So in the paper folding experiment, we were given these pre-cut out triangles and we were asked to figure out if Zach's claim is true. So what we did in class was we folded our isosceles triangle right down the middle so that our vertices matched up to construct or draw our line of symmetry, which would have been right here. And so what we noticed when we did that is the two triangles overlapped perfectly, or they coincided. So every side length coincided and every angle measure coincided. So when we opened that isosceles triangle, we could definitely say, based on our previous investigation in this class, that this isosceles triangle, we know these two sides are congruent by definition of an isosceles triangle. And then we know that if when we fold this over, these two sides coincide, then we know that these two lengths or legs of those triangles will be congruent. And because that third side is a line of symmetry, we can mark it congruent to itself. So if we think back to our last investigation, we concluded that Zach's claim is true because we have two triangles here that we can say are congruent by side, side, side. So side, 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 congruent to side, side, side.
In part 2 of this lesson, we were asked to pick one of the following quadrilaterals to explore: a rectangle, a rhombus, and a square, and we were given definitions of each of these three quadrilaterals. We were asked to draw an example of the selected quadrilateral along with its diagonals, and we were asked to label the vertices.
So the first quadrilateral we looked at was a rhombus, and by definition, we saw that a rhombus has all four congruent side lengths. So we drew our rhombus and we drew our tick marks to demonstrate that all four of the side lengths of our rhombus were congruent in length. Then we were told to draw our diagonals, which we did, and label the intersection point N. So the next step is we separated our triangles here, and the first one we redrew was triangle ABD, which you can see right here to the right, and then we saw that the triangle above it, triangle BCD, would be another triangle in the rhombus. And what we notice is the BD, which we could call our line of reflection again, because this triangle would overlap or coincide very nicely, perfectly on top of this triangle on the left. So we know that our line of reflection BD must be the same length in both of those triangles if we separate them. So we drew two tick marks on each of those line of symmetries, and then we knew that since these were each one tick mark, we drew them as so. So we actually saw that these two triangles would be congruent by side, side, side triangle congruence criteria. Another set of triangles that we could draw in this diagram would be triangle ABC and triangle ADC. And again, what we notice, so we're looking at this triangle up here on the left and this triangle down here on the right. We notice that they share a line of reflection and line segment AC. So that has to be the same length in both. So we mark them with 3 tick marks. And then again, we have side, 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 congruent to side, side, side. So we can say that these 2 triangles would be congruent by side, 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 congruence, triangle congruence criteria.
So the next quadrilateral that we looked at was a rectangle. And for the rectangle, we're going to assume that opposite sides of the rectangle are congruent, in addition to the definition that they gave us that it has 4 right angles. The reason we can assume that is because by line symmetry, if we were to draw a line of symmetry, through the center, we would be able to fold the bottom half of our rectangle onto the top half perfectly. They would coincide perfectly. So we know that we have line symmetry right there and vertically down the center. So that's one way we can claim the opposite sides are congruent. And also from Unit 1, we know that a rectangle has 180 degrees of rotational symmetry. So we know that line segment AD would be congruent to line segment BC, and line segment AD would be congruent to line segment DC. Okay, so I've marked them congruent. So what we did in class is we actually separated our triangles. So I'm going to highlight the triangles that we separated here. We separated triangle ABD, so we're looking at this triangle here on the left in yellow. And we separated and redrew it down here so that we could see what the triangle looked like. And then we marked what was given and what we know. So we knew that BA and had 2 tick marks and AD had 1 tick mark. And then we took the second triangle and we highlighted that. So we're looking at triangle BCD, and I'll just take a different color. Triangle BCD. And we can see that line segment BC had 1 tick mark and line segment CD had 2. So if we view what's marked on my 2 diagrams, we can see that we have 2 triangles congruent there by side angle side congruence criteria. So we wrote that first one in our notes for the rectangle. We also know that if we come back up here, and I'm just going to erase a little bit of this, I'll rewrite what I need to. And so I'll remark opposite sides. We can also take a look at 2 other triangles that we said would be congruent. Triangle ABC. So then we are focusing on the triangle up here in the top left corner. And then the triangle in the bottom right corner. So those 2 triangles there, and we wrote those down that triangle ABC would be congruent to triangle CDA by SAS triangle congruence criteria. We then moved on to the square, and I could demonstrate that, but we did the same thing. We drew our diagonals from vertex to vertex, and we labeled the intersection of those diagonals point N. And then we compared our triangles. We redrew them to see what triangles would be congruent, and then we wrote those in our notes. While we were investigating part 2 of this lesson, we did write our information in the organized table, which is in your MVP booklet. So I've demonstrated an example of when we looked at triangle ABD. On the previous example, it was congruent to triangle CBD, and the reason was side, side, side. And this is our rhombus that we started off class with. So AB was congruent to CD, and AD was congruent to CB because the sides of a rhombus are congruent, and BD was congruent to DB because the diagonal was shared in both triangles. So we continued to fill out this table as we worked in class. If you need more help on the Ready, Set, Go homework for this task, please remember to check the Canvas Student Support site.